Welcome to today's lesson on buffers. You can refer to textbook section 19.5 salts in solution. What do you think of when you hear the word buffer? Maybe you think of it as something that prevents you from coming in contact with something else. However, in chemistry, it means that a solution resists changes in pH. A buffer resists changes in pH when a small amount of acid or a small amount of base are added to the buffer system. A buffer consists of a weak acid or a weak base and one of its salts. One important buffer system that our bodies rely on is the buffers in your blood. Your blood's pH is between 7.35 and 7.45, and your body wants to keep the pH at that range. So there are buffer systems in your blood that keep the pH consistent. However, if the pH drops below 7.35, your body goes into something that we call acidosis. If the pH goes above 7.45, your body will go into something that we call alkalosis. So how do these buffer systems work? We're going to look at a buffer solution that consists of ethanoic acid and sodium ethanoate. These are salts that we've actually looked at in the last lesson that we had, pHs in salt solution, and you'll notice that sodium ethanoate actually completely ionizes because it is a salt. And you can see that by this reaction that I have just starred here. So in solution, if we were to look at a beaker of this solution, we would have ethanoic acid and we would have the ethanoate ion at equilibrium. We'd also have some of the sodium ions floating around too, since that is part of the buffer. So we're going to actually look at two scenarios that could happen to this buffer system. The first scenario we'll look at is the addition of acid, and then we'll look at a scenario where we add a base to this particular buffer system. So I'm going to draw a beaker of our solution so that you can see what's in this solution. So we have ethanoic acid. We also are going to have some of the ethanoate ion. And remember, I said there's sodium ions in there too, but the sodium ions aren't going to play a part in what is happening when we add an acid to this buffer system. So right now we're going to add an acid. We know acids can be designated using an H+, so that's what I'm going to use in this particular example. So I'm adding this acid to the solution, or hydrogen ions to the solution, and the only thing in this solution that are going to accept those hydrogen ions would be the ethanoate ion. So what's going to happen is that H is going to attach on because the ethanoate ion is going to act like a Bronsted-Lowry base, and it's going to be a hydrogen ion acceptor. So it's going to take on that hydrogen ion and it's going to form ethanoic acid. Ethanoic acid is going to stay intact. It's not going to dissociate in this solution. It's not going to ionize, or that hydrogen's not going to be released from the ethanoic acid. So because it's going to stay intact, the hydrogen ions get swept up or used up by any of those ethanoate ions that are in the buffer solution, and it causes the solution pH to stay very stable. Because there's no free hydrogen floating around, they've actually all attached onto any free ethanoate ions in that solution to form that ethanoic acid. So now I'm going to draw the same solution, like so. I'm going to show that we have each buffer system does have a buffer capacity. What this means is that if too much acid or base is added to the system, there would be a pH change in that buffer system. The buffer capacity is the amount of acid or base added before there is a big change in that pH. So buffer capacity, could it be 2 drops? Could it be 2 milliliters? That's just something that would have to be tested to find out what that buffer capacity is. Most times we use a titration setup and an indicator that we would then titrate to determine the buffer capacity. And titration is something that you've actually been able to do in lab, thank goodness. We were able to get that in before our closure. On the following slides, we're going to look at how adding too much or too much acid or too much base, how does it affect that buffer system? So in terms of our example, again, I'm going to draw our system on the slide. And in here we have, in here we have our ethanoic acid, and we have our ethanoate ions, like so. And again, we also have the sodium. Now let's just say in this particular solution now we're going to add way too much of the hydrogen ions or the acid. Let's just say we're going to add 5 hydrogen ions to this solution. Well, in this solution, you see I only have 1 ethanoate ion. So one of those 5 hydrogen ions could be used up here to form the ethanoic acid. But that leaves 4 hydrogen ions floating around in this solution, like so. And I'll just circle them so they kind of stand out a little bit. Now I've got excess hydrogen ions in this solution. When there's excess hydrogen ions that are not going to be consumed because there's no more ethanoate ions, now the solution becomes acidic and we've exceeded that buffer capacity in that buffer system. Now I'm going to do the same thing on this slide to show you what happens if we add too much hydroxide ion. So again, we have ethanoic acid, we have our ethanoate ions, like so, and now this time let's just say I'm going to add 5 units of base, or hydroxide ion. Here I'm going to add this to the ethanoic acid, and remember that pulls off that hydrogen to form water, and also the ethanoate ion, like so. But that only is going to use up 1 of my hydroxide ions. Also, I'm going to have left all of these excess hydroxide ions, 4 of them to be exact. And now, because I have all of these excess hydroxide ions, the solution is going to be basic and that pH is going to change. Our buffer capacity has been exceeded and the pH is going to shift to a more basic pH. Let's take some time now to practice with another example. This is actually from your textbook and you can refer to page 622 in your text to follow along. We're looking at the carbonic acid and the hydrogen carbonate buffer, and I just want to write out what the carbonic acid formula is. Carbonic acid is H2CO3, and the hydrogen carbonate is where it's lost a hydrogen. and has a negative charge, so HCO3 minus. So in the beaker, we would have our HCO3 minus, and we'd have some H2CO3 intact. And there'd also be a salt floating around there, whatever salt was used in this, it doesn't tell us. But that would also be in there, but it doesn't have any effect on the buffer system because it doesn't attract hydrogens. It doesn't mop them up, as we like to say. So the first thing we're going to do here is look and see what happens when we add a base. So when we add a base, we know we're adding the hydroxide ion to that particular solution. And so we're going to really be taking a look at the what's happening to the carbonic acid. So that's the H2CO3. That's going to be our weak acid, or what's going to donate a proton. And it's going to donate it to that Bronsted-Lowry base or proton acceptor. And because it's doing that, it's going to form the ion and water, the HCO3 ion and water. The formation of water, obviously that's neutral, and the hydrogen carbonate ion doesn't affect the pH. So as long as we don't have any excess OH going into that buffer system, the pH is going to stay pretty consistent. So this is the reaction that we would be looking at if we were adding a base. Now let me show you what happens when we add an acid. So let me erase what we just did and change this to adding the hydroxide ion, or not hydroxide, hydrogen ion, sorry about that. And you can probably guess what the reaction is going to look like here. Here the hydrogen carbonate ion, the HCO3 minus, is going to attract that hydrogen ion to it, and it's going to form carbonic acid. And carbonic acid, again, is going to not dissociate. The ion mops up those excess hydrogen ions, and because the carbonic acid doesn't dissociate, the pH stays pretty constant. Now, if we added excess hydrogen ions and there wasn't enough of the hydrogen carbonate ions to pick up those hydrogen ions, then the pH would get lower and your solution would become more acidic. But in this case, the question was just asking you to write that reaction, and this would be the reaction that you would write for the addition of hydrogen ions to that buffer system. So today's assignment, I'm used to saying tonight, but we're not in class, is to complete page 622 in your textbook, numbers 38, 41, and 43. And then I would like you to write a paragraph just explaining how your blood maintains the proper pH. So I want you to research the buffer systems. There's 2 buffer systems that are in your blood. And I want you to write a paragraph on how one of those buffer systems works. Don't forget to include the source that you use online. And please make sure that you type the paragraph. You don't have to write this one out. You should hand this assignment in through the Dropbox, and you can do one Dropbox for both assignments, so do them in the same document and just attach that document to the Dropbox.